Welcome, and thank you for joining the Sensing Storm Surge Citizen Science team. The following video is broken up into several modules that will take you through what you need to know to participate as a citizen scientist. We are happy to have you on our team and encourage you to reach out to us at any point with questions or concerns. We can be contacted via email, phone, or through our website.
Let's begin with a training overview. As mentioned previously, this training video is broken up into several modules to help you as you begin your journey as a citizen scientist. First, we will introduce you to the project personnel who are working on the Sensing Storm Surge team. From there, we will give you an introduction to storm surge by giving you a definition of storm surge and explaining its relevance to the state of Maine. Next, we will introduce the study objectives and research questions. From there, we will dive into the basics. We will give you an overview of your citizen science kit and introduce you to all the tools you will be using as a citizen scientist. Next, we will demo the data collection and data retrieval methods you will be using. To finish up that section, we will go over some safety considerations. To end our training video, we will go over a timeline and expectations of your new role as a citizen scientist. At any point, if you have any questions, please pause this video and reach out to us via email or phone. The Storm Surge team is comprised of 2 faculty investigators from the University of Maine, Dr. Laura Rickard, who is an assistant professor of communication and journalism, and Dr. Kimberly Huguenard, an assistant professor of civil and environmental engineering. A co-collaborator on the project is Dr. Abe Miller Rushing from Acadia National Park. 3 students are also working on the team. 2 PhD students in communication and journalism, Kevin Duffy and Abby Roach, and 1 undergraduate student, Kaya Lucky, from the Civil and Environmental Engineering program. We will now give some background on storm surge. Storm surge is the abnormal rise in water level that accompanies a coastal storm. There are 2 elements of surge, a wind-driven component and a pressure-driven component. When a storm sits off the coast and blows wind toward the shore, that wind drives surface water in that direction, which builds up along the coast. Additionally, since these storms are low-pressure systems, there is a water response called the inverse barometer effect. The low pressure in the storm acts to suck water up and results in an increase in water level under the storm. These combined elements represent storm surge, which can propagate along the coast as a long wave, similar to a tide. Storm surge flooding can be particularly dangerous in regions that feature large tidal ranges, such as in Maine. As you can see in this image, storm surge combined with the tide is called the storm tide. Flooding can be exacerbated when storm surge occurs during high tide. Previous research has shown that the shape of the continental shelf can greatly impact storm surge levels. For example, mild continental shelves tend to intensify storm surge levels more than steeper shelves, as shown in this video. As you can see, the beach is flooded when surge encounters a mild continental shelf. Now let's take an example specific to the state of Maine. In February 1976, a nor'easter sat off the coast of the Penobscot Bay and blew wind toward the coast. This event happened to correspond with high tide, which resulted in rapid flooding upriver. In Bangor, 12 feet of water flooded downtown in less than 15 minutes. This caught the community off guard, as shown in these pictures. This event caused approximately $10 million in damage in today's equivalents. The surge levels were amplified by the Penobscot River's funneling shape. So what do we know about storm surge? At present, we know that in naturally converging estuaries, storm surge is amplified as you travel upstream. Coastal natural buffers, such as wetlands, can decrease storm surge levels. However, these must be very wide. We don't have a solid understanding of how other estuarine characteristics affect surge levels and speeds, such as size, orientation, channel geometry, and bottom composition. A better understanding of this behavior is important for Maine because of coastal infrastructure, coastal economic development, and climate change adaptation. Recent research has shown that by 2050, extreme 100-year storm events will occur every 10 years, which has initiated local conversations on coastal adaptation. The Lincoln County Planning Commission has been modeling inundation from sea level rise and storm surge along several regions in Maine. This picture shows inundation, which is the blue overlay, in downtown Daramuscata, near the head of the Daramuscata River. This picture shows 1 meter of sea level rise and storm surge from a 100-year storm event. However, this type of prediction is static and doesn't include the influence of the river on surge levels. Nonetheless, vulnerable infrastructure has been identified by red shapes. In discussing climate change adaptations, there are basically 3 options. 1. Do nothing and lose the infrastructure. 2. Use hard armoring to combat rising water levels. Or 3. There may be greener alternatives. The town of Daramuscata is currently discussing option 2 by putting a seawall around the historic portion of downtown. If a better understanding of surge behaviors in estuaries is gained, then strategically placing vegetation or kelp curtains may be a viable alternative to mitigating storm surge flooding upriver. Now let's talk about the study objectives that are guiding this project. Our first objective is to develop a better understanding of storm surge behavior in 3 main estuaries, those being the Bagaduce River, Penobscot River, and Bass Harbor, each with varying physical properties. Our second objective is to engage local residents in data gathering using various training methods. Our third objective is to evaluate the citizen science effort by measuring data reliability and participants' engagement. Now that we understand the research objectives, let's jump into the research questions. We have 3 research questions that we are asking in this study. The first research question is asking, does involvement in a citizen science project affect cognitive, affective, and behavioral engagement in storm surge-related issues? Our second and third research questions are in many ways connected. We are interested in how different types of trainings affect engagement and the reliability of physical data. Now let's get into the basics. We'll start by overviewing the project equipment that you will find in your Citizen Science Kit. The first thing you'll find in your Citizen Science Kit is the Citizen Science Guide. This guide was written to help guide you in your new role as a citizen scientist. In addition to reaching out to us via email or phone, we encourage you to refer to the Citizen Science Guide with any questions. Next, you'll find the HoboWare Pro software. This software is meant to help you in the launching, reading out, and plotting of data from Hobo data loggers. This software will be downloaded onto your personal computer. Instructions on how to download this software can be found in your Citizen Science Guide, and we will be covering it later in this video. You'll also find the Water Level Logger. This logger will be explained in the following segment.
This is the Hobo Water Level Logger. It uses a ceramic pressure sensor to take absolute pressure readings, which later get converted to water level by the HoboWare software. Because this logger uses a ceramic pressure sensor to record data, this logger is very fragile, so it's very important that it is never dropped or bumped against anything that could damage it.
Your kit also includes a waterproof shuttle. This shuttle reads out all logger information from the loggers in the water. The next video will help us better understand the waterproof shuttle.
The waterproof shuttle can be brought into the field to collect data from the water level logger. The waterproof shuttle then can be plugged into the computer and the data will be offloaded using HoboWare software. The way that the waterproof shuttle connects to a computer is through this end. You unscrew the cap, and inside is a port that can be connected to a cord. One end of this cord plugs into the waterproof shuttle, and the other end plugs into a USB port in your computer.
You will also find the logger mooring system in your Citizen Science Kit. The mooring system houses the logger and protects it during field deployment. In addition, it ensures that the logger stays in a fixed position underwater. The following video will give us a better understanding of the logger mooring system.
This is the concrete mooring platform you will be using to house the water level logger. The logger will be inserted into this PVC pipe, and this entire system will be placed in the water with the rope and buoy tied off to a water front structure.
You will also find scissors and zip ties used for deployment in your citizen science kit. As a refresher, your field site is a site that is unique to you as a participant. This site is one that you have talked about with someone from the project personnel. Your field site should be accessible by land and allow for the logger and mooring system to be submerged under a foot of water at all times, even during low tide. In addition, you should feel comfortable and safe at this site. If you have any questions about your field site, please do not hesitate to contact us. We will now begin the process of installing HoboWare. Please note there are two separate ways of installing HoboWare. One way is to utilize the CD-ROM that is included in your Citizen Science Kit. The other, if you do not have a CD-ROM drive on your personal computer, is to visit the HoboWare website. Both of these options are described in the following videos.
In this segment, we will be installing the HoboWare software onto your computer. To begin, insert the CD in your computer's CD-ROM drive. The installation should start automatically. If it does not, navigate to the CD drive in My Computer and double-click hoboware_setup.exe to launch the HoboWare installer. In this segment, we will be installing the HoboWare software onto your computer. To begin, navigate to www.onsetcomp.com/hoboware-free-download. This is what the web page should look like. Now locate the link that says Download HoboWare for Windows and click on it. It should begin downloading. You should see a pop-up at the bottom of the window. Click on the arrow and select Open when done, so that the file opens automatically after it is finished downloading. Now that we have the Setup Assistant, we can begin the installation for HoboWare. English should be the default language, so now click OK. HoboWare for Windows requires the Java runtime environment. If the correct version of Java is not already installed on your computer, the HoboWare Setup program will ask if you want to install it now. You will see a message window that looks like this. If you don't see this message, that means that the correct version of Java is installed on your computer and you can skip ahead. If you need to install it, click Yes. Now click Install. Now that Java is installed, the HoboWare installation can continue. Go ahead and close the Java window. This is the HoboWare Setup Wizard. Click Next. This is the software license agreement. Click I accept the agreement and then click Next to continue. This is asking you to select a location on your computer where the program will be installed. The default is under Program Files, and this is generally where all of your computer programs are located. However, if you would like to change this, you can click Browse and pick a different folder. The default usually works well. Click Next. This is telling you that a program shortcut will be created in your Start menu. It will be convenient to have a shortcut to HoboWare in your Start menu now that you'll be using it, so go ahead and click Next. This is asking if you would like to create a desktop icon for HoboWare. You can check or uncheck this box to create a desktop shortcut, then click Next. Now click Install. Once the installation is complete, this window will pop up. And before we click Finish, uncheck this box that says README. If checked, this opens a Word document that is unnecessary for what we are doing. So go ahead and click Finish now. Once you click Finish, HoboWare should open automatically, but if it doesn't, you can launch HoboWare by clicking the desktop icon you created or by going to your Start menu. When you first open HoboWare, you will be asked about checking for updates. Go ahead and click No. Now this is the HoboWare Setup Assistant that will guide us through a couple of program settings before we get started. These will ensure that HoboWare is operating the way we want it to for this project. Click Start. Click USB Devices Only and then click Next. For the unit system, we don't want US, we want SI, so go ahead and change that and click Next. Now you should see two checkboxes that say Linear Scaling Assistant and Pulse Scaling Assistant. Go ahead and uncheck both boxes and then click Next. Now click Next again. Now we are done with the setup, so click Done. As you collect data each month, you will need a folder on your computer to save the HoboWare files you will be creating. Choose a location, like your desktop, and create a new folder. You can do this by right-clicking, scrolling down to New, and then clicking on Folder. You can call this folder anything you want. However, some ideas would be HoboWare Files, Storm Surge Project, or Storm Surge Files. Every time you take data from the sensor and offload it onto your computer using HoboWare, this will be the place that you save the data file. From this folder, you will be able to upload the data files to the Storm Surge project website.
We will now begin a demo of data collection and field preparation. Let's start by talking through the first launch, or the first time that you will connect your logger to a computer. This step is done before you ever take the logger into your field site. This first launch helps us set up the logger so it is ready to begin collecting data. The first step is connecting the logger to a computer. To begin, unscrew the black plastic end cap from the logger by turning it counterclockwise. If the coupler is not already attached to the water shuttle, attach it to the water shuttle by pressing the two ends together. You may have to press pretty hard. Next, insert the logger into the coupler with the flat end on the logger aligned with the arrow on the coupler. Gently twist the logger to be sure that it is properly seated in the coupler. It should not turn. As you can see here, the two ridges are lining up. Now that the logger and water shuttle are connected, you can use the USB interface cable, which is a black cord, to connect the water shuttle to the computer. First, unscrew the small cap on the end of the water shuttle. If the cap is too tight to loosen by hand, insert a screwdriver through the lanyard hole and rotate counterclockwise until the cap is loosened. Next, plug the small end of the USB interface cable, again the black cord, into the USB port in the shuttle. Next, plug the large end of the USB interface cable into a USB port on the computer. Before opening HoboWare, check the time on your computer and ensure that it is correct. If it is not, update your computer's clock manually or synchronize it with an online time server. Now you are ready to open HoboWare. Once HoboWare is open, briefly press the coupler level, hard enough to bend the lever. It may take a few seconds for the device to be detected by the computer. When you are pressing the coupler level, make sure that you do press it hard enough. Once the device is recognized, the status bar at the bottom of the window should look like the one that the yellow arrow is pointing to. Note, if the device has never been connected to this computer before, it may take some time for the computer to detect the new hardware and report that it has been connected successfully. One or more messages will appear indicating that new hardware has been found. You may also hear a chime. Just as a warning, do not leave the logger in the coupler for extended periods of time. When connected to the coupler, the logger is awake and consumes significantly more power than when it is disconnected and considered asleep. Always remove the logger from the Hobo waterproof shuttle as soon as possible after launching, reading out, or checking the status to avoid draining the battery. Now that the logger is connected, we will configure the data logging settings. First, click on the Device menu at the top of the window, and then scroll to Launch in the drop-down menu. To set up the logger to record data, there are two settings that need to be adjusted in the Launch window, and they are both under the Deployment section. First, find Logging Interval. Click on the drop-down menu and select Custom. Type 2 in the Min window. This sets the logger to record data every 2 minutes. Next, find Start Logging. It should already be set on Date Time. This setting is up to you. Select a date and a time that you can be sure that the logger will be deployed, meaning that it will be in the water at your field site. Once you have adjusted these settings, the window should look similar to the photo displayed on the screen now. Click on Delayed Start at the bottom right corner of the launch window to launch the logger with these settings. Now that we have HoboWare and the logger system set up, we're ready to deploy the logger and mooring system at your field site. Before going into the field, please remember to bring the following items: the mooring system, the logger, zip ties, your citizen science guide for reference, a cell phone camera or other device to take photographs, and appropriate outdoor gear like boots, gloves, and sunglasses. The next video will give you an overview on how to secure the logger to the mooring when you are ready to deploy the logger mooring system at your field site.
This is the concrete mooring platform you will be using to house the water level logger. The logger will be inserted into this PVC pipe, and this entire system will be placed in the water with the rope and buoy tied off to a waterfront structure. Now, to secure the logger inside the PVC pipe, we will be using a zip tie. To begin, place the logger inside the PVC pipe, and next, place the zip tie through the side where the hole in the PVC is. Once you make the zip tie go through the side of the PVC, you should then insert the zip tie into the cap of the logger that has two holes, through one side and out the other. There is a second hole on the other side of the PVC pipe where you will then insert the zip tie. So now the zip tie is going from one end of the PVC to the other through the holes in the caps of the logger. Then you can secure the zip tie, and the system is ready to go.
Now let's talk about the mooring placement. As mentioned in the basics section of this video, you will need to make sure that you place the mooring in a location that will ensure that the logger will be submerged in at least 1 foot of water at all times, even at low tide. If you are tying your mooring system off to a waterfront structure, such as a pier, tree, or rock, you are going to need to know how to tie a secure knot. The knot you should use is the bowline knot. If you're not familiar with the bowline knot, a link to the video of how to tie a bowline knot can be found on our website, or you can find the web address in the Citizen Science Guidebook. The next part of our training will go over data collection and retrieval.
After you remove the mooring platform from the water to collect your data, you will begin by taking a pair of scissors or a knife and snipping the zip tie that is securing the logger. This allows you to slide the logger out of the PVC pipe in order to offload the data. Once the water level logger has collected sufficient data, you will bring the waterproof shuttle into the field to offload the data from the logger. The way that the logger and the water shuttle communicate is using something called a coupler. To begin, insert the coupler onto the water shuttle like this, making sure that it is secure. The next step is to unscrew the cap off of the water level logger. This reveals the optic interface that will then communicate with the water shuttle. In order to insert the logger into the coupler and therefore have it communicate with the water shuttle, you need to align two things. The first is a ridge on the logger, and the second is a ridge on the coupler. Once you align them, you can push the water level logger into the coupler. This is what it should look like. The ridge on the coupler is lined with the ridge on the logger. To begin offloading the data from the logger to the water shuttle, press down on this lever right here. You should see the LED lights on the shuttle light up. There are 3 lights: OK, transfer, and fail. The green light corresponds to OK, the yellow light corresponds to transfer, and the red light corresponds to fail. Now when you first press down on this lever, you should see the transfer light blinking. This means that data is being offloaded from the logger to the water shuttle. When the transfer is complete, the green light will begin blinking, and at any point now you can just go ahead and remove the logger from the water shuttle. The green light will continue to blink for 10 minutes after you remove the logger. This is a normal function. If you would like to stop the green light blinking, simply press down on the lever again.
Once you have offloaded data from the logger onto the water shuttle, remove the logger from the coupler. You will then replace the cap on the logger. Following the steps previously outlined in this video, make sure to secure the logger back into the mooring system using a zip tie. Once the mooring system is ready to go, replace it in the same location in the water. Now that you have successfully offloaded the data from the logger onto the water shuttle and replaced the mooring system back in the water, you are ready to connect the water shuttle to your home computer to upload data to the computer and later to the website. The first step will be to unscrew the small cap on the end of the water shuttle. If the cap is too tight to loosen by hand, insert a screwdriver through the lanyard hole and rotate counterclockwise until the cap is loosened. Next, you will plug the small end of the USB interface cable, which is a black cord, into the USB port in the shuttle. Next, you will place the large end of the USB interface cable into a USB port on your computer. At this point, the water shuttle should be connected to your computer. You will next open the HoboWare program. It may take a few seconds for the water shuttle to be recognized by HoboWare. Once the water shuttle is recognized, the status bar at the bottom of the window will look like this. You will then go to the upper left-hand corner and go to Device. Scroll down to Readout. This will allow us to read out the data from the shuttle. HoboWare will now prompt you to save the data file. Use the default location and click Save Checked in the bottom right corner of the window. Now that the data file has been saved to your computer, you need to launch the shuttle before you can unplug it. To do this, click Launch Shuttle in the bottom right corner of the window. After you have clicked the Launch Shuttle, a message window may appear asking if you are sure you want to launch the shuttle. Click Yes. The shuttle should now be launched, which means you can unplug the shuttle from the computer. We are now ready to upload the data to the website. The following videos will walk us through this process. To begin uploading data from your computer onto the online database, you will need to visit the project website. Type the project website into your browser. Once you're on the website, click Log In on the upper right-hand side of the site. Then type in your participant username, which is your email address, and your password. If you forget your username or password, please contact Chris Wilson at cwilsn28@gmail.com. After you have successfully logged in and you are on the dashboard page, click the Add Record button on the left-hand side of the page. Once the Add Record button has been pushed, a dialog box will appear that will prompt you to enter your username, site location, date of data upload, answers to various journal prompts. After you've inserted your username, site location, date of data upload, and answered the various journal prompts, including the uploading of any photographs, click the Choose File button to begin uploading water level data. Once you've clicked Choose File button, a dialog box will appear prompting you to choose a file to upload. Choose the data file you wish to upload and press Open. Your data is now ready to be submitted. In order to submit your data, press the Submit button in the middle dialog box. Before ending this section, we would like to go over some safety procedures. As a brief overview, each citizen scientist must read over and sign a safety procedure form before participating in the project. This form will either be emailed to you or given to you in person. We also encourage citizen scientists to follow the following safety guidelines. Alert others when you go out to collect data. Check the weather. Wear appropriate gear. And always be aware of your surroundings. This now concludes the demo of data collection and field practice portion of the video. As we now near the end of this training video, we would like to review the monthly expectations. First, all citizen scientists are expected to retrieve and upload logger data to the online database. This happens once a month.
If for some reason you need to change your schedule in relation to retrieving data, that is okay. Please just make sure that you never allow the logger mooring system to stay in the water for over 30 days.
Scientists are also expected to respond to several short questions when they upload the data to the website. Additionally, we ask that you upload a photo of your research site. This upload of a photo helps us see what you're seeing and will give us a project. We ask that you please fill out pre- and post-project surveys. These surveys help us better understand how you are experiencing the program and how you are experiencing storm surge and your knowledge on storm surge. We will also be hosting a Science Cafe event in your area at the conclusion of this project in March of 2018. We hope that these Science Cafe events will be a time for us to share the data back with you and with your fellow community members. We also have optional interviews. These interviews will be taking place from fall 2017 into spring of 2018. If you would like to participate in an optional interview, please contact us or we will contact you to ask if you are interested.
We are happy to have you on the team and encourage you to reach out to us at any point with questions or concerns. We can be contacted via email, phone, or through our website.
As we wrap up this training video, we would like to leave you with some resources and contact information. We encourage you to visit our website and to utilize the Citizen Science Training Guidebook when you run into questions. If you find yourself in need of assistance with your logger and/or HoboWare software, please email Kyle Lucky. If you find yourself needing assistance with data upload and/or the website, please email Chris Wilson. If you have general questions about the project, please email either Dr. Kimberly Huguenard or Dr. Laura Rickard. We would like to thank you again for being a part of this project, and thank you also for watching this video training tutorial. We would like to acknowledge the University of Maine, CNET, the National Science Foundation, and Maine EPSCoR for helping provide support to make this project possible.